Hello! We have been looking at ideal auctions. We are at a point where, given an allocation rule that maximizes welfare, we wish to find a payment rule so that it is DSIC. Recall that we want DSIC so that players are incentivized to bid their valuations. This not only benefits the player by getting their maximum utility, it also achieves the overall goal of social welfare. We will derive this payment rule using Myerson's lemma. Now, Myerson's lemma characterizes auctions that do have the DSIC payment rule and gives a formula for the payment rule. In this lecture, we will do the setup of the background needed to get to this lemma, and we will state it. We will then prove some cases of the lemma in the next lecture. We start with an abstraction of the auction model. In a single parameter environment, we are given a set of players N, a private valuation Vi for each player I, which is player I's valuation for one unit of goods, and a set X of vectors x1 to xn that describes feasible allocations. That is, xi is the amount of goods given to player I. Note that this is single parameter since each player has only one piece of private information. For example, in a single item auction, X is the set of all standard basis vectors in Rn. These are n tuples with 1 1 and n-1 zeros. And that is because we have one item that is given to exactly one player. In the sponsored search auction, X is the set of vectors where, for each slot J, at most one player I satisfies Xi is equal to alpha J, the click-through rate for slot J, and it is 0 otherwise. We are interested in mechanisms in this environment, that is, rules of the auction. We let B be the set of all possible player bids. We assume all bids are non-negative. And here is our definition. Given a single parameter environment, a direct revelation mechanism will do the following things. It collects bids B from all players. It chooses a feasible allocation X of B based on the bids. And it chooses a payment P of B where player I pays Pi of B. We call the function X that maps bids to allocations an allocation rule, and the function P that maps bids to real vectors a payment rule. Given this set of rules, the utility for a player I is Ui of B, which is Vi times Xi of B minus Pi of B. Vi Xi of B is the total value that player I receives, their valuation times how much they get. And we subtract the amount they pay, Pi of B. As part of the DSIC condition, we will assume that 0 is less than or equal to Pi of B, which is less than or equal to Vi Xi of B. That is, truthful bidding will result in non-negative utility. For example, for the second price auction, the allocation rule is Xi of B, which is 1 when Bi is the maximum bid in B, and it is 0 otherwise. The payment rule Pi of B is the second highest bid, maximum of Bj for j not equal to I, when Bi is the maximum bid, and it is 0 otherwise. Now there are two terms for an allocation rule that we'll be discussing here. An allocation rule X is implementable if there exists a payment rule P such that XP is DSIC. This means that after we have decided on an allocation rule, Can we find the payment rule such that it is DSIC? If it is, then we can implement this allocation rule. For example, in the single item auction, the allocation rule where we give the item to the highest bidder is implementable. We can implement this allocation rule by using the second price rule as payment. Our second term here is monotone. An allocation rule X is monotone if, for all players I and for all the other bits B minus I, xi of z b minus I is at least xi of y b minus I whenever z is at least y. Translation: the higher you bid, the more you get. For the single item auction, highest bid wins is monotone. But if we change the allocation rule to second highest bid wins, this is no longer a monotone allocation rule. You can lose things by bidding higher. You can check easily that for sponsored search auction, the welfare maximizing rule is monotone. We are now ready to state Myerson's lemma. For a single parameter environment, an allocation rule is implementable if and only if it is monotone. Moreover, given a monotone allocation rule X, there exists a unique payment rule P such that XP is DSIC, and the payment PI of B is 0 whenever the bid BI is 0. We will prove this theorem for some special cases in the next lecture.